Hello students, very good morning. Welcome to Narayana Life Classes. Today for class 10 students, we are going to discuss assignment number 20 on differentiation. Let us start with the first question. The set of points where the function f of x is equal to x mod x is differentiable. When do you say that a function is differentiable at a point? Okay, suppose at point A, we are observing a function f of x, whether it is differentiable or not. What is the test? We have to find out LHD and RHD and we have to prove that they are equal. What is LHD? Left hand derivative. What is RHD? Right hand derivative. If at all the function is f of x, LHD is defined as limit x tends to a minus f of x minus f of a by x minus a. What is RHD? Limit x tends to a plus f of x minus f of a by x minus a. If both are existing and equal, then we say that the function is differentiable at x is equal to a. What is that? At x is equal to a, if at all you want to prove that the function is differentiable, what is the procedure? We have to find out left hand derivative at a and right hand derivative at a. For right hand derivative, what is the rule? Limit x tends to a minus f of x minus f of a by x minus a. For right hand derivative, limit x tends to a plus f of x minus f of a by x minus a. This is the formula we have to use in finding LHD and RHD. After getting LHD, RHD, both must exist finitely. Both must have some finite values and must be equal. If both are existing finitely and equal, then we say that the function is differentiable at that point. Okay, so using that concept, we are going to solve this question. Now, if you all see, look at the given function, we are given f of x as x mod x. Here x is an algebraic thing, it's okay, polynomial. Mod x is critical here. Mod x is very important to observe. Mod x, whenever you have, what you have to observe is, mod x means inside the modulus we have a function some x. X, if you take x as 0, that function becomes 0. So x is equal to 0 is to be the critical point here for mod x function. What I mean to say is, suppose you have a function mod of x minus a. At x is equal to a, x minus a becomes 0. That is a critical point what I am trying to say. At that particular critical point, we have to observe the nature of mod x. There only there will be a problem whether it is differentiable at that point or not differentiable at that point. Only at that point the problem arises. I mean to say we have to observe very critically whether it is differentiable or not. So it is crucial to observe x mod x at x0 because the critical point is 0 for that. Less than 0 means 0 minus what is the nature? 0 plus what is the nature? Means if LSD at 0, RSD at 0. If both are existing finitely and equal, then we say that it is differentiable at 0. If that is differentiable at 0, that is differentiable throughout. Because only 0 is the problem for this question. Problem in the sense critical point for this question. Rest of the points it is automatically differentiable. Fine. So we have to observe LSD and RSD of this function at 0. That's what we are trying to do. For that, what I am trying to do, fx let us define, this is x mod x. So I can define x mod x. If x is less than 0, what is the function? Minus x square. Because mod x is minus x if x is less than 0. If x is more than or equal to 0, what is the function? X square. Because mod x is x. Once you got this, find out f dash of x directly. That is minus 2x if x less than 0, 2x if x more than or equal to 0. Okay. Now LSD let us observe. LSD. What is LSD? F dash of 0 minus. F dash of 0 minus. Already you have f dash of x minus 2x at x less than 0. Means this is going to be minus 2 into 0. That is 0. Next R is let us find out. That is f dash of 0 plus. F dash of 0 plus is how much? 2 times of 0. That is also 0. Here both LSD and RSD are existing as 0. Means both are finite. Of course they are equal. They are finite and equal. So if the function is differentiable at 0. If that is differentiable at 0, the function is differentiable throughout R. Whatever x you take as the point we are observing, there the function is definitely differentiable. So the function is differentiable on real numbers. Real numbers otherwise we represent as minus infinity to plus infinity. So that is the right answer. Okay. Now let us see the next question. We are given a split function. See, fx is x if x less than 1, fx is a minus x if x lies between 1 and 3 and including them. That is, if x more than 3, we have x square minus 4x plus 3. We have given a split function where it is not differentiable. Whether it is differentiable or not, how to check, where to check, that is point. We have to check at critical points. What are they? 1 and 3. 1 and 3. That's all. At 1, LSD, RSD you find out. At 3, LSD, RSD you find out. The same way. If LSD and RSD are existing finitely and they are equal, means that is differentiable at 1 if you are observing at 1. At 3, if LSD is equal to RSD, equal and existing finitely and equal, then we say that it is differentiable at 3. If not, it is not differentiable, right? Let us check at 1 as well as at 3. If at all LSDs and RSDs are existing and equal, then we say that it is differentiable at 1 as well as at 3. Okay, now let us proceed. Now, first step is what? Finding LSD at 1 means f dash of 1 minus. F dash of 1 minus. How to write it? Limit x tends to 1 minus f of x minus f of 1 by x minus 1. That is how it is defined. That is equal to limit x tends to 1 minus, let me write as 1. After that, for 1 minus, I choose the function. Okay, what is 1 minus? The function value x, because x less than 1 means it is function x. X minus f of 1 means x is equal to 1 means this function I have to see. If x is 1, 3 minus 1 becomes 2 by x minus 1. X minus 2 by x minus 1. If at all I take x as 1, 1 minus 2 minus 1 by 0. Some constant upon 0 is not a defined value. So, it is not a finite value. Undefined value, right? So, it's not undefined. It is undefined. Next, f dash of 1 plus. F dash of 1 plus means limit x tends to 1 plus f of x minus f of 1 by x minus 1. That is, limit x tends to 1 plus, I will write as 1. For 1 plus, I choose a function. What is f of x function? If 1 plus is there, 3 minus x. So, that is 3 minus x minus f of 1 value is 2 again. F of 1 is how much? F of 1 is 2 by x minus 1. Right? So, that we have limit x tends to 1, 3 minus 2. 3 minus 2 means 1 minus x by x minus 1. That is going to be minus 1 of course. This is going to be minus 1 because 1 minus x, if I write as minus of x minus 1 by x minus 1, both will cancel and we are left with minus 1 here. Here we have undefined value, whereas in this case we have minus 1, finite. One is undefined, other is finite. Means definitely they are not same. So it is not differentiable at x is equal to 1. The function is not differentiable at x is equal to 1 because LSD and RSD are not same. Because one of them is not existing. So that itself is correct to say it is not differentiable at that particular point. So at 1 it is not differentiable. Now let us check with 3. So at 1 is already over. Now let us find out f dash of 3 minus. That is limit x tends to 3 minus f of x minus f of 3 by x minus 3. That is limit x tends to 3 I will take and 3 minus I will choose a function. For 3 minus less than 3, the function is 3 minus x. 3 minus x minus, what is f of 3? F of 3 means 3 minus 3, it becomes 0 by x minus 3. What is the resultant value? Minus 1, because x minus 3 means minus of x minus 3, I will write minus of x minus 3 by x minus 3 is minus 1. Limit x tends to 3 minus 1 is minus 1 itself. Similarly, f dash of 3 plus, that is limit x tends to 3 plus f of x minus f of 3 by x minus 3. That is limit x tends to 3 I will write, and for 3 plus I will choose a function. For 3 plus means more than 3, the function is x square minus 4x plus 3. X square minus 4x plus 3. Okay? Minus f of 3 is 0, neglecting by x minus 3. Now I can simplify it further. That is limit x tends to 3. I can write it as x minus 1 into x minus 3. Numerator I can split into two factors, x minus 1 and x minus 3 by x minus 3. These two will cancel. Now I write x as 3, I have 2 minus 1, that is 1. 2 minus 1, that is 1. Here LHD is minus 1, RSD is plus 1. Both are existing, but they are different from one another. So definitely it is correct to say that it is not differentiable at 3 also. So not differentiable 3 also. Okay, so the function fx is not differentiable at 1 and 3. 2 and 4 are in between points. 4 is more than 3 value. So definitely they are differentiable at those points, because if it is 2, the function is 3 minus x. Linear function is differentiable. Next, if x is 4, the function is x square minus 4x plus 3. It is a quadratic function, that is also differentiable everywhere. So that here only at 1 and 3 the function is not differentiable. So 1 and 3 are the right options. Next, if fx is equal to x power p cos 1 by x when x not equal to 0, 0 when x is 0. Okay, fx is differentiable at what values of x? X is 0, then value of p can be. He is saying that it can be differentiable at x0 for certain values of p. What are the values? Let us see this. We can say f dash of 0 is limit x tends to 0. Okay. Here what we have to see is at 0, f dash of 0, how to write f dash of a? We have a formula. F dash of a is given by limit x tends to a, f of x minus f of a by x minus a. That is what is given for us. F dash of 0 is given by limit x tends to 0, f of x minus f of 0 by x minus 0. That is what is given. That is otherwise limit x tends to 0, f of x means x power p cos of 1 by x minus f of 0 is given as 0 by x minus 0 is x of course. So what do you have now? That is limit x tends to 0, x power p minus 1 times of cos of 1 by x. It must exist. Why it must exist? Because it is differentiable, he is saying. If it must exist, here this particular p minus 1 value must be more than 1. P minus 1 must be more than 1. Then only we have some x, then 0 times of some bounded value. Cos 1 by 0 is a bounded value. 0 times of that bounded value is 0. So p must be more than 1. For p more than 1, it is 2. Take this. P more than 1 means all 3 options. 1, 2 as well as 3. That is the right option. Let us see the last question. D by dx of 1 plus x square plus x power 4 by 1 plus x plus x square is ax plus b. Then what is a comma b? It looks to be very tough question. But here we need to do one thing. 1 plus x square plus x power 4 I will write as x power 4 plus 2x square plus 1 minus x square. Let us add up and subtract x square. It is otherwise x square plus 1 whole square minus x square. So this can be written as a square minus b square form. A plus b into a minus b. Fine. Then what is the value of 1 plus x square plus x power 4 by x square plus x plus 1 value? Nothing but x square minus x plus 1. Right? So we divide both the sides with x square plus x plus 1. We have x square minus x plus 1. Differentiation, if you want to differentiate it, d by dx means differentiating the given function with respect to x. That is going to be d by dx of x square minus x plus 1. What is d by dx of x square minus 2x plus 1? d by dx of x square is 2x minus d by dx of x is 1 and d by dx of constant is 0. According to fundamental rules of differentiation, whenever you have plus or minus in between function, individually we can differentiate them. And derivative of a constant 0, d by dx of x power n is n into x power n minus 1, right? Using that I got the value as 2x minus 1. That is equivalent to ax plus b, he is saying. So, if I equate it to ax plus b, what is a? A is 2, b is minus 1. A is 2, b is minus 1. So, 2 comma minus 1 is a comma b value. 2 comma minus 1 is nothing but third option for us. That is the right answer. Okay. So, that is the end of this assignment. Thank you. Have a great day.